Hello, boys and girls. We are on chapter 12. Can you believe it? This book only has 13 chapters and you're on chapter 12. That's amazing. Okay, so this is chapter 12, lesson 1, measurement benchmarks. Okay, so measurement is, measuring things, and benchmarks are kind of important measurements that you can feel or visualize, or you understand them pretty quickly. Okay, fraction benchmarks, like 1/2 is a fraction benchmark. These are measurement benchmarks. Okay, so customary units are units that we in America basically use. Okay, and you can see all these examples: ounce, pound, inch, foot, yard, mile, gallon, cup. Those are the benchmarks that we use, because an ounce, if you know a lot about measurement, you'll know an ounce is pretty light. It's mass, and it's a pretty light amount. And a pound is, maybe like one big book, like a big hardcover book is about a pound. Okay, so all of these should be measurements that you can kind of visualize or understand pretty quickly. Okay, so the directions on here say use benchmarks to choose the customary unit you would use to measure each. So if you were trying to find the weight of a table, okay, you should be able to pretty quickly choose one of these measurement benchmarks. So if I were weighing a table, that would be a customary unit that would measure weight. Okay, so that measures length, that measures length, that measures weight. That measures weight. All right, let's look over here. Yard length, mile length, gallon is volume, and cup is volume. Okay, so we really, for weight, have to choose from ounce or pound. Ounces are pretty light, and like I said, pounds are like a big hardcover book. So if I were going to weigh a table, I would use pounds. Okay, so the amount of liquid a bathtub holds. All right, so let's go through these again. That's length, 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 length. So I wouldn't measure how long liquid in a bathtub is, right? I would measure the volume. So that's going to be either gallons or cups. Now, a gallon, is like a milk gallon. They're kind of squared off plastic with the handle built in. Okay, and then a cup's like a teacup. Okay, it's maybe like half a water bottle that you would buy. Okay, so would you use a gallon or a cup to measure what's in a bathtub? Well, I would use a gallon because a bathtub can hold a lot of water, right? Okay, so those are some measurement benchmarks for customary units. Let's keep going. Now, these are benchmarks for metric units. And metric units are what scientists use, and a lot of people all around the world use metric units. Okay, you're going to be learning a lot about these in this chapter. A milliliter, well, let me write these. A liter, that's volume. Okay, that's filling something. So anything that has liter at the end of it is going to be volume. A gram, grams are mass, weight, okay? So anything with gram at the end of it is going to be, you're going to be thinking about how heavy something is. And then there's meter, M-E-T-E-R, and that's length. That's how long things are. So anything you see with meter on the end, or just the word meter, those are going to be how long things are. Okay, so let's see. The amount of liquid a water bottle holds. So the amount of liquid is going to be volume, so we're thinking liter. So let's see, here are our 2 liter choices, milliliter and liter. Now a milliliter is like drops of liquid, such a little bit. And then a regular old liter, that would be like a pretty big water bottle, like a big tall water bottle, is a liter. Sometimes you can buy liters of soda. They're like skinny but tall, okay? So if I were thinking about a water bottle, I would not measure that in milliliters because they're teeny. I would think about them in liters. So number 8 is the length of a pencil. Okay, so length is going to be meters. The length of a pencil, pencils aren't super long, right? I know some of my students use pencils that are like little teeny nubs. It drives me crazy. I always try to give them long pencils. Okay, so length is meter. So we have centimeter, meter, and kilometer. All right, a centimeter is if you look at your pinky, the tip of your pinky, and you look across your pinky nail there, that's about a centimeter. And a meter is if you stretch your arms out, that's about a meter, maybe a little longer than a meter. Okay? And then a kilometer, I like to think of kilometers like miles. They're not exactly the same, but kilometers are pretty long. So I would not measure a pencil in kilometers. Okay? I wouldn't measure pencils in meters either. Like if you stretch your arms out, well, that would be a cool pencil, but that's pretty long. I would measure pencils in centimeters. Okay? So this lesson is really giving you an idea of what all these measurements mean. Well, let's keep going. Okay, it says circle the better estimate. So these are not exact, right? These are estimates. So number 9 says the mass of a chicken egg. So imagine you have a chicken egg in your hand, okay? So grams, I don't know, a gram is like I use a lot of dry erase markers, Expo markers. So one of those markers is about a gram. And a kilogram is like a pound-ish, okay? So have you ever seen a chicken egg that weighs 50 pounds? That would be like 50 hardcover books on top of each other. No, no, no. That is not what a chicken egg weighs about. It's about 50 grams, okay? And then number 10, the length of a car. Okay, so now these were metric units, so we kind of have to think about those. These are customary units, and that's what we use all the time. So if you think about the length of a car, would you ever think about a 12-mile long car? That would be, again, a very cool car, but pretty long. You couldn't even drive it. A car is about 12 feet long, okay? And a foot literally is about as long as an adult's foot. That's what feet are. All right, let's keep going. So this is on the back, the lesson check. Which is the best estimate for the weight of a stapler? Okay, so again, like put your hand out and put your teacher's metal stapler in your hand. Feeling that, okay? So let's look at our choices. Oh, they're all in 4. 4 ounces, 4 pounds, 4 inches, and 4 feet. Now, right away, I'm pausing there at 4 feet, right? Like 4 feet. We're talking about weight. Do you measure weight in feet? Like if somebody says, hey, how much do you weigh? Do you say, I weigh 4 feet? No, that's not weight, is it? Okay, and then I'm just glancing up here at C. Inches, that's not weight either. Both of these are length, so they can both be eliminated. So think about the stapler. Is it ounces or pounds? Now remember we said a pound is a hardcover, a pretty big hardcover book. So think about 4 of those books on top of each other. Is that what a stapler weighs? That would that would be a very heavy stapler. Can you imagine your teacher picking up a 4-pound stapler? Staple your papers. No, a stapler is about 4 ounces. Okay? Nice job, guys. All right, here we are on review. Chapter 8, Lesson 4. It says, Bart practices his trumpet 1 1/4 hours each day. How many hours will he practice in 6 days. All right, so let's see here. I'm going to reread this one again. So Bart practices his trumpet 1 1/4 hours each day. So every day, that's how long he practices. So they're asking, how many hours will he practice in 6 days? So he practices 6 days, 6 days of 1 1/4 hours, right? So he does 1 1/4 6 times. Okay, so how many hours is that? All right, so when we multiply a whole number by a mixed number, remember mixed numbers? Mixed numbers are made of a whole number and a fraction, right? When we multiply by a mixed number, I bet you guys have learned a couple of different strategies, right? Maybe you've broken this apart and done like the distributive property. But the strategy that I'm going to use is I'm going to change this mixed number into a fraction greater than 1. And then I can multiply 6 times the numerator. Okay? So 6 times 1 1/4. Just to be sure I get all the parts multiplied, I am going to make 1 1/4 a fraction greater than 1. So I have one set of 4 pieces. Remember, that's what my one whole thing is made of. It's made of 4 pieces. That's that one. And then I have 1/4 in addition to that. So I have one set of 4 plus one more piece. So 1 times 4 is 4, plus one more piece equals 5. So I have 5 out of 4 pieces that make the whole thing. Okay, 1 times 4 is 4, plus 1 is 5. So let me rewrite this over here. I kind of made I'm globbing up my workspace. So instead of using 1 1/4, I'm going to write 5/4 because 5/4 is equivalent to 1 1/4. 6 sets of these 5 pieces. Okay, 6 times 5 is 30 over, ooh, that looks like 36. There we go, 30 over 4 pieces because we didn't change that, right? So 30/4. But look at these choices. None of those say 30/4, do they? So what I'm going to do is make 30/4 a mixed number. Now let's remember, you have 30 pieces. Every time you group 4 of those pieces together, you make a whole. So we are going to go 30 divided by 4 to see how many sets of those 4 pieces we can get from the 30. Okay, so let me think about 4 into 30. 4, 8, 12. You probably know this by now, right? When we first started this, you needed to do that all the time, but I bet you know your times tables great. Okay, so 28, 32. But wait a minute, do we have 32 pieces? No, we only have 28 pieces. So 1, 2, 3, 4, 5, 6, 7. So I can take 7 sets of 4 pieces out of the 30, that's 28 pieces, and I have 2 pieces left over. So look at my choices here. So that's 8 whole things, 6 whole things. So B and C both have the 7 whole things, but I had those 2 pieces left over, remember? So it's 7 and 2 out of 4 left over, 2/4 hours. Okay? Which you guys know now is equivalent to 7 1/2, right? A little fun fact at the end. All right, guys, excellent work. I'll see you soon.